Welcome back, Libromaniacs. So I'm going to be reading a couple pages from the book, the excellent book, Cosmo Sapiens, Human Evolution from the Origin of the Universe by John Hands. I'm going to read the end of chapter 4 and the beginning of chapter 5. And the end of chapter 4 begins with conclusions, which are briefly summarizing the points made in this chapter. Conclusions. Chapter 3 concluded that cosmology's orthodox theory is unreliable, and the central claims of inflation, added to explain admitted contradictions in observational evidence, is almost certainly untestable. This chapter has concluded that, even with two major add-ons, dark matter and dark energy, the current theory fails to provide convincing answers to 6 key questions. Whether or not, and if so, how the universe originated as a singularity. How did matter form from the energy released by the Big Bang so as to produce the ratio of matter to energy observed today? What is the dark matter apparently needed to explain why galaxies and galactic clusters don't fly apart? And what and where is the far greater additional dark matter needed to explain why the rate of expansion of the universe is that predicted by theory? How and when did this slowing rate of expansion apparently change to an accelerating one? And what is the dark energy invoked as the cause? How and why did the universe take the form that it did when many other forms were possible? And crucially, how was everything created out of nothing when the originating vacuum bubble has a ground state energy and so is not nothing? In 1989, Nature published an editorial describing the Big Bang model as, quote, unacceptable, unquote, and predicting that, quote, it is unlikely to survive the decade ahead, unquote. It has survived longer than that. The inflationary hot Big Bang is still cosmology's orthodox explanation for the origin of the universe, but for how much longer? Other hypotheses are competing to either modify the orthodox model or else supersede it. Do they provide a more scientifically rigorous account of the origin of the universe? And that leads us into chapter 5, which is called Other Cosmological Conjectures, which begins with 2 quotes. The first quote, seeking an alternative to the orthodox model is just plain good science. Science proceeds most rapidly when there are 2 or more competing ideas. That is by Paul Steinhardt in 2004. The second quote, many of today's practicing theorists seem to be unconcerned that their hypotheses should eventually confront objective, real-world observations. That is by Michael Riordan in 2003. Some cosmologists, unlike some popes, are unhappy with the idea that the universe exploded into existence from nothing. For them, the idea that the universe is eternal is far more appealing. One difficulty in evaluating their ideas and other alternatives to the orthodox inflationary Big Bang model is that, just as most of the literature on religion is written by believers in particular religions, so too most of the literature on cosmological speculation is written by believers in particular speculations. Like their religious counterparts, they are sometimes less than objective when presenting their hypotheses and selecting and interpreting claimed supporting evidence. I have chosen what I think are the most significant ideas. Some comments on the conclusion and the beginning of chapter 5. So in the conclusion, this book talks about the 1989 Nature article, the editorial, saying that the Big Bang model was unacceptable. That's crazy that since 1989, people have been saying, this is the editor of Nature magazine is saying that the Big Bang theory is unacceptable, and he predicted that it's unlikely to survive the decade ahead. Now, as noted by John Hands, it has survived, but it's only because we don't have a better theory. Like, it's that convoluted. So it's like, well, this is the worst possible theory in our toolbox of theories, but it's the best we've got in this scenario. And it's interesting also that second quote at the beginning of chapter 5, that's almost tongue-in-cheek. Today's practicing theorists seem unconcerned that their hypotheses should eventually confront objective real-world observations. Like, that's how lost in the woods we are on some of this stuff. That these guys can just, theorize and theorize and theorize all day, and they don't really have to be smacked in the face by actual data from real-world observations. So those are two comments to take note of. Now we're going to turn to one of the other cosmological theories in this chapter, in chapter 5, and we're going to read a page about plasma cosmology. Plasma Cosmology. In his 1991 book, The Big Bang Never Happened, plasma physicist Eric Lerner compiled observational evidence that contradicts orthodox cosmology's model. This, he maintained, is a repackaged myth of a universe created from nothing that violates one of the best tested laws in physics, the principle of conservation of energy. Moreover, in order to reconcile the mathematical model with observation, it requires three major conjectures: an inflation field, dark matter, and dark energy, that have no empirical support. Based on the work of plasma physicist and Nobel laureate, it's kind of a tongue twister for me, Hans Alvren, Lerner proposed a cosmology that he claims accounts for astronomical observations by empirically established plasma physics and gravity. He assumes, like the proponents of the orthodox model, a Euclidean or flat geometry, the kind with which we are familiar, for the universe, but proposes that it does not have a beginning or an end and is not expanding. According to Lerner, within this non-expanding universe, plasma filamentation theory predicts the formation of intermediate mass stars during the formation of galaxies and the observed abundance of the light elements. Large-scale structures such as galaxies, clusters, and superclusters form from magnetically confined vortex filaments. Since the conjecture proposes no beginning for the universe, there is no limit to the time it takes for observed large-scale structures to evolve from an initial disordered plasma. Radiation emitted by early generations of stars provides the energy for CMB, cosmic microwave background. This energy is thermalized and isotropized by a thicket of dense magnetically confined plasma filaments that pervade the intergalactic medium. This accurately matches the CMB spectrum and predicts the observed absorption of radio waves. Furthermore, the alignment of CMB anisotropy, which contradicts orthodox cosmology, is explained by the density of absorbing filaments being higher locally along the axis of the local supercluster and lower at right angles to this axis. Many orthodox cosmologists dismiss Lerner as not a serious scientist, largely, I suspect, because he is not an academic. He is president of Lawrenceville Plasma Physics, Inc., which undertakes research in fusion energy, a member of the Institute of Electrical and Electronic Engineers, the American Physical Society, and the American Astronomical Society, and has published more than 600 articles. The evidence he cites includes many papers from academic astronomers, and in 2014 he co-authored a paper with two such astronomers that compares the size and brightness of about 1,000 nearby and extremely distant galaxies. He claims these contradict the surface brightness predicted by an expanding universe, but are consistent with a non-expanding universe. What may be termed plasma cosmology's static evolutionary universe model proposes an eternal universe, and unlike QSSC, quasi-steady state cosmology, it does not require the creation of matter from nothing. It explains the observed evolution of the universe as an interaction of known physical forces, electromagnetism, gravity, and the nuclear reactions within stars and by cosmic rays. However, as currently developed, it doesn't explain what caused the initial disordered plasma of an eternal universe to exist, and what caused these known physical forces to exist and interact in such a way to produce successively more ordered, complex states of matter. some comments on that. I heard about plasma cosmology before I read Cosmo Sapiens. So this particular section, I've actually read the Big Lerner's Eric Lerner's Big Bang Never Happened. Um, I've also read. I think I've read The Electric Universe by the Thunderbolts guys, the guys who do the Thunderbolts website. Um, I have not read The Electric Sky yet, though. That is one that is still on my list of plasma cosmology books to read. So I was watching videos on the Thunderbolts website and watching us. Actually, I have them on YouTube as well. And from reading those books, you learn that wow, they're making, with plasma, you can make these little mini galaxies, like these little, they look like little Milky Ways, these little spinning plasma vortexes that look identical to galaxies. And apparently, something that's interesting about plasma is that it scales up, like it goes like all the way to the top of the magnitudes of order. I think, just off the top of my head, I want to say it's like 20 magnitudes of order. So how plasma behaves at this tiny, tiny scale is also how it behaves at this like galactic scale. And so if you can create these little plasma vortexes that look like galaxies, well, then that means real galaxies can form the same way, just on a larger scale. And so it's like that pair or like that